In this experiment, we will use flame tests to identify various substances. As always, it will be necessary that you have your lab report at hand and that you make sure you record the necessary data. As you watch this lab, refer to this chart found in your manual. We begin by preparing several solutions using metals from groups 1 and 2 in the periodic table. To make sure that our tests are accurate, we have rinsed 8 test tubes with a 6 molar solution of hydrochloric acid before placing 2 grams of the compounds in the test tubes as shown. We have added 5 milliliters of distilled water to each test tube. We also put unknown compounds in 3 additional test tubes labeled unknown A, B, and C. In order to identify the metals present in these unknowns, we will perform the flame tests on the known substances. That will generate the data that we need to identify the unknown substances. What we are attempting to do is to conduct a qualitative analysis of the substances. By that, we mean we will try to identify which substances are present. If we were trying to figure out how much of the substance is present, we would conduct a quantitative analysis. We will do qualitative analysis of the substances by conducting flame tests. This type of test requires us to first identify the flame color produced for each of our known substances. We will do this by using a platinum wire and dipping it into the known solution, then putting the wire into the flame to see the color it produces. It is very important that between tests the wire is cleaned in hydrochloric acid so that we don't get any misreads. Observe what happens when each substance is tested. Notice the lithium compound in test tube number 1 produces a red flame. Write this observation in your lab manual. We will repeat the procedure for test tube number 2. Write the flame color of sodium chloride in your manual. We will do the same thing for the compound in test tube number 3, sodium nitrate, and record the color of the flame. Observe that the sodium compound has the same yellow color as the sodium chloride. If we tested other sodium compounds, the same characteristic yellow flame would be evident. We can conclude from this that every time sodium is present, it will produce a yellow flame. We also now know that the flame test works for metal ions, not other compounds, since changing the other ion present in the molecule did not affect the results. Let's continue with the other tests. We have cleaned the wire and will perform the flame test for potassium chloride. What color is the flame? Write your observation on your manual. Let's test calcium chloride. Enter the color of the flame test. Now strontium chloride. Enter the color of this flame test. What color is the flame for barium chloride? Enter the color of this flame test. Now we will test a mixture of 2 different metals, sodium chloride and potassium chloride. Notice that we obtain the same yellow color we obtained before when we were testing just sodium. Sometimes this may happen, and this color can mask other metals present. In order to check for other metals, we will look through a cobalt blue glass. The yellow color can be absorbed and reveal other colors and metals present in the solution. Now, what other colors can you see? We need to conduct 3 tests. First, let's see what it looks like with the sodium chloride solution. The yellow color has been absorbed. Now, let's do the same thing with the potassium chloride. We now can see the violet from the potassium. Now we will repeat the process with the solution that is combining both. Notice how we can only see the violet since the yellow is being absorbed by the glass. Enter this data. Since we have just finished testing all of our known substances, it is now time to test the unknown ones in order to compare and be able to identify the metals present in them. Let's begin. First, unknown substance A. Observe and enter the color. Next, unknown substance B. Enter the color. Finally, unknown substance C. Enter the color. In conclusion, we have used heat to excite electrons from metals in families 1 and 2 and cause them to jump energy levels, radiating the excess energy back in the form of light. This light exhibited a particular color. By comparing the colors produced in the flames of the known substances to those that are unknown, we can identify the metals present in the latter. We also learned that these colors belong to specific atoms. It is now time for you to complete your lab report.